welcome. Tonight, we are going to look at the timeline of our world. When we walk through a natural history museum or when we run our fingers over the glossy pages of a geology textbook, we are presented with a comforting illusion. We see a straight, unbroken line. We see the era of bacteria flowing seamlessly into the age of fish, which crawls onto land to become the age of reptiles, which eventually gives way to the age of mammals. It feels complete. It feels like a finished story written by a diligent author who recorded every single event since the beginning of time. But this sense of continuity is a deception. The history of the Earth is not a book. It is a heap of torn pages saved from a house fire. The ground beneath our feet, the rock record that we rely on to tell us who we are and where we came from, is not a perfect archive. It is an archive defined by amnesia. For every year that is preserved in stone, 1,000 years have been erased. For every fossil we find, 1 billion lives have vanished into dust without leaving a trace. Tonight, we are not going to look at what is there. We are going to look at what is missing. We are entering the unexplained gaps. We will travel to the Grand Canyon, where a geologist can place their hand on a rock face and touch a boundary where 1 billion years of history has simply vanished. We will look for the ghost lineages, the missing ancestors that must have existed to bridge the gap between water and land, but who have left no bones behind. We will ask where the atmosphere went for 1 billion years, and we will search for the lost planet that collided with us to create the Moon. These are the black holes of history, the moments when the Earth stopped recording or when it deliberately destroyed the evidence. But before we step into these voids, take a moment to anchor yourself in the present. If you find this slow drift into the mystery of deep time to be a quiet comfort, I'd be grateful if you'd like the video and subscribe. But do so only if you genuinely enjoy the journey we take here. And let me know in the comments, does the idea of a lost history make you feel curious, or does it make you feel small? Now, find your comfortable position. Dim the lights. Perhaps turn on a fan for that soft, steady background hum. Let it remind you of the wind blowing through an empty, ancient canyon. We are entering the library, but the lights are out, the shelves are toppled, and the pages are scattered on the floor. We can only read the silence between the words. The first silence we will encounter is in the story of life itself. At the most critical junction of our own history, the fossil record goes dark just when it should shine brightest. We all know the story of evolution as it is usually told. We know of the brave, lobe-finned fish, creatures like Tiktaalik, pulling themselves out of the Devonian swamps with primitive limbs, taking that first gasping breath of air. We celebrate this moment. It is the great transition, the moment our ancestors decided to conquer the dry ground. After this first step, we imagine the story continues triumphantly, a steady march of amphibians growing stronger, legs growing longer, lungs growing deeper. But if you look at the fossil record, the story stops. Immediately after the first fish apods crawl onto the mud, the lights go out. For the next 15 million years, a span of time longer than the entire existence of the human species, the rock record is almost completely empty of four-legged animals. This is Romer's Gap. It dates from roughly 360 to 345 million years ago, the early Carboniferous period. It is a biological blackout. We have the fish at the beginning, and 15 million years later, we have fully formed, diverse, and complex amphibians walking around. But the middle, the teenage years of land life, gone. Where are the fossils of the struggle? Where are the bones of the creatures that learned how to walk without dragging their bellies? Where are the first true lungs? For decades, paleontologists thought this was simply bad luck. They thought we just hadn't dug in the right places. But as we mapped the globe, the silence persisted. It wasn't a failure of digging, it was a failure of the world. The leading theory is terrifying. It suggests that the gap exists because the air itself became hostile. Geochemical models paint a grim picture of this era. The oxygen that fills our lungs today, that lets us run and think and dream, had drained away. The atmosphere had thinned to perhaps half of its current richness. A modern human transported to this world would gasp, struggle, and grow dizzy, not from poison, but from sheer absence. It was like trying to breathe at the summit of Everest, but standing at sea level. The Earth had become a gasping world. Imagine a planet of endless, stagnant swamps where the air is too thin to support active life. The brave pioneers who had crawled out of the water found themselves suffocating on the beach. They may have been forced back into the water or driven into tiny specialized niches where they left no trace. Evolution did not stop, but it was throttled, forced into a bottleneck of low energy. The most important physical transformation in the history of our lineage, the engineering of the leg, the rib cage, and the lung, happened in the dark, in a world that was trying to smother it. We are the children of a 15-million-year struggle for breath that we can never witness. And while our distant ancestors fought for every breath on those mudflats, the ground beneath them was quietly witnessing the rise of a different empire. In the shadows of the ferns and the rotting logs, something else was stirring. A dynasty was awakening that would eventually claim dominion over the skies themselves. We live in the age of insects. In terms of sheer numbers, diversity, and biomass, this is their planet. We are just guests. We assume that their conquest of the Earth was a steady, documented march. We imagine a clear line of evolution from the first creeping bug to the masters of the air. But the fossil record tells a different, more unsettling story. It tells us that the insects did not just evolve, they appeared. There is a period in the rock record, roughly overlapping with Romer's Gap, but extending even longer, known as the Hexapoda Gap. It is a 60-million-year blackout. Before this gap, in the Devonian period, the insect ancestors are humble. They are small, wingless, silverfish-like creatures scuttling through the moss. They are earthbound, prisoners of the soil. Then, the record goes dark. For 60 million years, the rocks are silent. It is as if the entire lineage vanished. But when the lights come back on in the Carboniferous period, the world has changed completely. The insects have returned, but they are no longer the humble scavengers of the moss. They are titans, and most importantly, they are flying. This is the great, unexplained leap. In that dark, unrecorded silence, nature performed an engineering miracle. It invented flight. This is not a trivial development. The evolution of the wing is one of the most complex biomechanical puzzles in history. How do you go from a crawling leg to a fluttering wing? Where are the intermediate stages? Where are the gliding insects, the prototypes, the failed experiments? The entire process of how life learned to conquer the sky is missing. It is as if a civilization went from the horse and cart to the jet engine without ever leaving a record of the steam train or the propeller. The gap hides the most significant revolution in the history of movement. The leading theory suggests that the plants were the trigger. As the first forests grew tall, creating a vertical world of resources high above the ground, the insects were forced to adapt. They climbed, and in the low oxygen, high-density atmosphere, they perhaps began to glide using modified gills or solar panels on their backs. But we can only guess. The rocks refuse to speak. When the fossil record finally resumes, the insect blackout ends with a roar. The sky is suddenly filled with meganeura, dragonflies the size of hawks. The forest floor is patrolled by arthropleura, millipedes the size of crocodiles. The silence of the gap birthed monsters. The world had gone into the dark as a quiet, flat landscape of creeping things. It emerged as a three-dimensional, buzzing, humming empire of giants. The gap did not just hide history, it accelerated it. These biological blackouts, the gasping vertebrates, the vanishing insects, occurred while life struggled with a suffocating atmosphere. They were catastrophes of chemistry, quiet disasters written in thinning air. Yet they were not the only tragedies hidden in the fossil record. Long before the famous extinctions that headline our textbooks, there were dynasties that rose to absolute power and then fell in complete silence. Empires erased so thoroughly that we didn't even know to mourn them. We often view the history of life as a series of clear chapters defined by their endings. The dinosaurs ended with an asteroid. The Paleozoic ended with the Great Dying. But there are tragedies hidden within the chapters, silent catastrophes that wiped out entire dynasties without leaving a headline in the geological news. One of the most haunting of these is Olson's Gap. It sits in the middle of the Permian period, roughly 270 million years ago. This was a time long before the first dinosaur. It was the age of the pelycosaurs, the magnificent sail-backed reptiles like Dimetrodon that we often mistake for dinosaurs in our toy sets. They were the undisputed kings of the land, apex predators that had ruled for millions of years. And then, the film reel snaps. For a period of perhaps several million years, the global fossil record goes dark. The rich, diverse layers of the early Permian suddenly stop. When the record resumes, the world has been completely rewritten. The magnificent Dimetrodon and its kin are gone, vanished. In their place stands a completely new ruling class, the Therapsids. These are the beast faces, the direct ancestors of mammals. They are uglier, hardier, and physiologically more advanced. The gap marks a violent changing of the guard. It is as if a king died and a usurper took the throne, but the history book containing the war was burned. For decades, scientists called this a preservation artifact. They argued that the rock simply eroded away, that we were missing the pages, not the animals. But recent evidence suggests something darker. Olson's Gap was likely a secret mass extinction. We believe the world suddenly became intensely hot. The tropical rainforests of Pangaea collapsed, replaced by brutal, arid deserts. The food web disintegrated. The sail-backed reptiles trapped in their drying swamps starved to death. The gap is not just a silence, it is a heatstroke. It was a dress rehearsal for the end of the world, but unlike the famous extinctions, this one happened in the shadows. It is a reminder that a dynasty can fall in the dark, and we may never know exactly how it happened. Olson's Gap shows us how swiftly a ruling class can vanish from the earth. One moment, the sail-backed kings patrol their swamps. The next, their bones are dust, and their thrones are occupied by strangers. It is a sobering lesson in impermanence. Yet what comes next reveals something even more disturbing. Not just the fall of a dynasty, but the near-total failure of life itself. A time when the planet was so broken, so wounded, that it forgot how to make new creatures at all. The end Permian extinction, 252 million years ago, was the closest life on Earth ever came to total annihilation. Volcanoes in Siberia burned the world. The oceans turned to acid, and 95% of all species died. We know this. But what we often forget is what happened next. We assume that nature abhors a vacuum. We assume that once the volcanoes stopped smoking, life would rush back in to fill the empty Earth, exploding in a riot of new evolution. But it didn't. For the next 5 to 10 million years, an eternity in biological time, the Earth was a dead zone. This is the recovery gap. The fossil record from the early Triassic is frighteningly sparse. It is a post-apocalyptic landscape. The complex ecosystems of the past are gone. The coral reefs are gone. The forests are gone. The The world is populated by disaster taxa, a few hardy, ugly generalist species like Lystrosaurus, a pig-sized burrower that spreads across the entire empty globe simply because there is nothing else to stop it. But the most profound evidence of this gap is not in the bones. It is in the rock itself. It is the coal gap. For hundreds of millions of years prior to this moment, the Earth had been burying dead trees, creating the vast coal seams that fueled our industrial revolution. But in the early Triassic, the coal stops. All over the world for millions of years, the geological strata contain zero coal. This silence screams. It means there were no forests. The heat was so intense, the acid rain so corrosive, that the trees simply could not grow. The planet was a barren, baked wasteland of mud and fungus. Or perhaps the fungi had evolved to become super-eaters, devouring the dead wood so fast that nothing remained to fossilize. Either way, the Earth had lost its ability to store carbon. The planetary machine was broken. This gap teaches us a terrifying lesson about resilience. The Earth can recover, yes, but it does not bounce back. It limps. It takes millions of years to heal a wound that deep. The gap is the time it takes for a fever to break. So far, we have walked through the missing biology of our world, the vanished ancestors, the insects that appeared fully formed, the silent extinctions, the forests that refused to grow. These are the torn pages in the book of life. Yet the missing pages of the Earth are not only biological. Sometimes the rock itself plays tricks on us. Sometimes the pages are not torn out at all. They are simply glued together so seamlessly, so invisibly, that we do not even realize centuries have vanished beneath our feet. The gaps we have explored so far, the biological blackouts, the recovery periods, are visible because the fossils disappear. But the Earth has a way of hiding time that is far more deceptive. It can steal 10 million years right from under our feet and leave the rock looking perfectly unbroken. Geologists call these paraconformities. They are the phantom layers of the world. Imagine a bricklayer building a wall. He lays a row of red bricks. Then he stops. He walks away for a year or a century or a millennium. In that time, the wind blows, the rain falls, but the wall stays exactly as it is. Then, the bricklayer returns and lays a new row of identical red bricks directly on top of the old ones. To an observer looking at the finished wall, there is no gap. The bricks fit perfectly. The mortar is seamless. There is no evidence that the builder ever left. But in the thin, invisible line between those two rows of bricks, 1,000 years of history have vanished. This happens in the rock record constantly. We find layers of sandstone or limestone stacked neatly on top of one another, parallel and flat. They look continuous. They look like an uninterrupted story of a calm, ancient sea. But when we analyze the microscopic crystals inside the rock or find a rare microfossil, the illusion shatters. We realize that the bottom layer is from the Jurassic period, and the layer directly above it, glued to it without a crack, is from the Cretaceous. Between them, 30 million years are missing. Where did they go? They were erased by non-deposition. For an eternity, the seabed simply stopped accumulating mud. The currents swept the floor clean, preventing any new history from being written. Or perhaps sediment did fall, but a subtle shift in the current scrubbed it away before it could turn to stone. This is the vacuum of the deep. It is a terrifying concept for a historian. It means that the ground we walk on is not a complete timeline. It is a supercut. It is a movie where the editor has snipped out hours of footage, but spliced the remaining scenes together so smoothly that the audience doesn't notice the jump. We are walking on a patchwork planet. We assume that if the rock is solid, the time is solid. But the paraconformities teach us that the rock is a liar. The most peaceful-looking cliff face might be hiding a gap larger than the entire history of the human race. These phantom layers hide their absence well. They are the con artists of geology, presenting a calm face while concealing millennia of emptiness. Yet sometimes the Earth is not so subtle. Sometimes the gap is not a hidden seam, but a violent, jagged scar. A wound so dramatic, so impossible to ignore, that it changed how we understand the very age of our planet. To witness this kind of break, we must travel to a windswept coast where a Scottish farmer turned naturalist made a discovery that shattered humanity's conception of time itself. In the year 1788, a small boat bobbed on the rough grey waters of the North Sea just off the coast of Scotland. In it sat a man named James Hutton. He was looking for proof that the Earth was old. At the time, the prevailing wisdom was that the planet was young, perhaps only 6,000 years old, a static stage created in a single week. But Hutton looked at the slow erosion of the Scottish hills, the slow deposition of sand in the rivers, and he knew the math didn't work. He knew there had to be more time. He directed the boat toward a rocky promontory known as Sychar Point, and there, exposed by the tide, he saw a formation that would break the human conception of history forever. He saw a geometric impossibility. At the bottom of the cliff, the layers of rock, grey shale and sandstone known as greywacke, were standing vertically. They were pointing straight up at the sky like the pages of a book standing on a shelf. But resting directly on top of them, creating a flat, horizontal roof, was a completely different layer of red sandstone. It was a T-junction in the geology. The vertical grey rock met the horizontal red rock at a perfect right angle. To the untrained eye, it was just a strange cliff, but Hutton saw the violence hidden in the geometry. He realized that the grey rocks at the bottom had originally been laid down flat on an ancient ocean floor. Then, over millions of years, they had been buried, turned to stone, and violently thrust upwards by the collision of continents until they stood vertical. Then they had been lifted above the water to become mountains. Then the gap happened. For those vertical mountains to become a flat surface for the red sandstone to rest on, they had to be eroded. Wind and rain had to scrub an entire mountain range down to a flat plain. That process alone would take eons. Only then did the ocean return, depositing the red sand that would become the top layer. Hutton realized that the line where the two rocks touched, the angular unconformity, was not just a crack, it was a missing timeline. At Sychar Point, that thin contact line represents a gap of 65 million years. 65 million years of mountains rising and falling, of storms raging, of life evolving, all erased, reduced to a single line of friction between grey and red stone. Hutton's companion on the boat, John Playfair, later wrote a sentence that captures the feeling of this discovery perfectly. He said that, as they stared at the rock, the mind seemed to grow giddy by looking so far into the abyss of time. It was a moment of vertigo. Humanity suddenly realized that we were not living at the beginning of the story. We were living in the middle of a book so vast that we couldn't even see the binding. Sychar Point proved that the Earth is a self-devouring machine. It builds archives and then destroys them. Hutton's discovery in Scotland was a dramatic, angular scar, impossible to miss once you understood what you were looking at. The violence was written in the geometry, in the impossible angle where two worlds collided. Yet, violence is not the only way the Earth erases its memory. Across the Atlantic, hidden beneath the green hills of the American heartland, lies evidence of a gentler, more insidious kind of destruction. Here, the Earth did not tear its pages, it dissolved them, slowly, chemically, one raindrop at a time. buried beneath the cornfields of the American Midwest and the green rolling hills of the Appalachians, lies a gap that tells a different story. It is not a story of crashing tectonic plates or vertical upheavals, but of a quiet chemical dissolution. This is the Knox Unconformity. To find the missing time here, one must look below the surface of the modern continent. If you strip away the soil of Ohio, Tennessee, or Kentucky, you find a boundary that represents a catastrophic failure of the Earth's memory. Imagine North America 450 million years ago, during the Ordovician period. It was not a land of prairies and forests. It was a tropical archipelago, rotated on its side and straddling the equator. A vast, shallow, sunlit sea covered the interior from New York to Texas. This was the Great American Carbonate Bank, a factory of stone similar to the modern Bahamas, but on a continental scale. For millions of years in the warm, clear water, microscopic life built layer upon layer of white lime mud, creating a limestone platform kilometers thick. But then the engine stopped. Far away, on the southern supercontinent of Gondwana, a sudden, sharp ice age began. Glaciers locked up the planet's fresh water. The global sea level plummeted. The vast inland ocean that covered North America drained away, exposing the white seabed to the air for the first time in eons. This exposure was a sentence of destruction. The atmosphere of the Ordovician was rich in carbon dioxide. When rain fell through this air, it turned slightly acidic. As it struck the exposed limestone plains, it didn't just wash them, it ate them. The chemistry of the weather attacked the chemistry of the stone. For 30 million years, the continent was a karst landscape, a dissolving ruin of white stone. Acidic rain carved deep sinkholes, vast underground caverns, and jagged pinnacles of rock. The surface was pitted and scarred, rotting away under the chemical assault. The sediment, the fossils, the physical record of that entire epoch were dissolved into liquid and washed into the abyss. When the ice finally melted and the seas rose again in the Silurian period, they deposited new layers of sand and mud on top of this eroded, uneven surface. But the damage was done. The contact point, the Knox boundary, remains as a jagged scar in the stratigraphic record. Drill down today, and you find the smooth, white Ordovician limestone, and sitting directly on top of it, the coarse Silurian sandstone. The line between them is rough, uneven, and distinct. It is the physical evidence of 30 million years of rotten time. But the most haunting part of this gap is the sand itself. The layer that sits above the missing time is the debris of a ghost. To the east, a mountain range was rising, the Taconic Mountains, the violent, jagged ancestors of the Appalachians. They were once as high and as terrifying as the Alps or the Andes, but during those missing 30 million years, the wind and rain scoured them down. The mountains were decapitated, their granite peaks were ground into sand, and that sand was washed west to cover the rotting limestone plains. The Knox Unconformity is a double grave. It is the empty space where a sea used to be, covered by the dust of mountains that no longer exist. It is the physical proof that even the highest peaks and the deepest stone platforms are temporary. We are walking on a crust that is constantly being erased. We have now seen several ways the Earth erases its rock record, through the grinding of erosion, the slow acid of chemistry, and the violent collision of tectonic plates. These are the mechanisms of forgetting, the tools the planet uses to edit its own autobiography. Yet there are mysteries that run even deeper than missing stone. There are contradictions so profound, so fundamental, that they suggest the very physics of our world was once different. To find the next void, we must stop looking at the ground beneath our feet. We must lift our gaze upward toward the star that warms us and ask a question that seems almost impossible. Why didn't the young Earth freeze solid? The gaps in the rock record are disturbing because they represent erased time. But there are other voids that are even more fundamental. These are gaps in physics itself, equations where the variables do not balance, suggesting that for the first half of our planet's life, something essential about our world was fundamentally different. To find the largest of these contradictions, we lift our eyes from the strata of the Earth and look at the star that keeps us alive. Stellar physics is a precise science. By studying stars at different stages of their life cycles across the galaxy, astronomers can rewind the history of our own sun with mathematical certainty. We know that stars like ours are not static. They brighten as they age. 4 billion years ago in the Archean Eon, the infant sun was different. It was smaller, it was weaker, it burned with a luminosity roughly 30% lower than it does today. If you were to stand on the surface of the primordial Earth, the daylight would have been strange, a dim, anemic glow like a light bulb running on low voltage. This leads to a simple thermodynamic calculation. If you take the modern Earth and turn down the sun by 30%, the global temperature collapses. The planet freezes. The oceans turn into solid blocks of ice from the poles to the equator. The Earth becomes a snowball, a dead white reflector of the weak starlight. But here is the paradox. When we look at the oldest rocks on Earth, the ancient Isua greenstone belt in Greenland or the Jack Hills zircons in Australia, we do not find evidence of ice. We find the opposite. We find pillow basalts, lava that cooled instantly underwater. We find ripple marks preserved in sandstone, the fossilized fingerprints of liquid waves lapping against a shore. We find evidence of a water cycle, of rain, of tides. The geology screams liquid ocean, the physics screams frozen Earth. Between these two realities lies a massive gap in our understanding. Something is missing from the equation. To keep the Earth warm under such a faint sun, the atmosphere must have been fundamentally different. It must have acted as a super insulator, a planetary blanket of immense thickness. The leading theory is a greenhouse overdose. Scientists speculate that the Archean sky was thick with carbon dioxide, perhaps hundreds of times the current level. Or perhaps the missing ingredient was methane, pumped out by the very first primitive bacteria, turning the sky a hazy, organic orange like the moon Titan. But the rock record for the atmosphere is gone. We cannot bottle the air of 4 billion years ago. The exact chemical composition that allowed the Earth to cheat death by freezing is a missing variable. We are here, living on a blue, liquid world, only because of a thermal mystery that we cannot fully explain. The atmosphere of the deep past is a ghost. It shielded the planet, nurtured the first life, and then vanished without leaving a chemical signature we can read. The ancient atmosphere hides its secrets in gases that have long since dissipated into space or been locked away in stone. It is an invisible mystery, a puzzle written in air that no longer exists. Yet there is another mystery that is far more tangible, one you can hold in your hand. If you look at the gold ring on your finger, or imagine a bar of platinum locked in a vault, you are looking at something that, according to the laws of planetary formation, should not exist on the surface of the Earth at all. The presence of these precious metals is not just a curiosity, it is evidence of a cosmic delivery, a second chapter in the formation of our world that we are only beginning to understand. The atmosphere hides its secrets in invisible gases, but the ground beneath us hides a mystery that is heavy, cold, and glittering. It is a paradox that you can touch. It is likely sitting on your finger right now. Look at a gold ring, or imagine a bar of platinum in a vault. We value these metals because they are rare, but according to the laws of planetary formation, they should not be rare. They should be non-existent. They should be gone. To understand this gap, we go back to the very beginning, to the Iron Catastrophe. When the infant Earth was just a ball of molten magma, It was a liquid, and in a liquid, gravity acts as a sorter. The heavy elements sink, and the light elements float. Gold, platinum, and iridium are heavy, siderophiles or iron-loving elements. In that primal melted world, every single ounce of these precious metals should have been dragged down by gravity, sinking through the magma ocean to bond with the iron in the core. The crust of the Earth, the thin, cool outer skin we live on, should be entirely depleted of them. It should be a barren shell of light silica and feldspar. You should not be able to mine gold in South Africa or find platinum in Russia. The surface should be empty of treasure. But it isn't. The gold is here. The platinum is here. This presence represents a massive gap in our timeline. It suggests that after the Earth cooled, after the core was sealed off and the crust hardened, something else happened. A second chapter that was not part of the original formation. Geologists call this the late Veneer. It suggests that the surface of our world is not original. It is a coating, a dusting of alien material delivered from the sky. Imagine a time roughly 4 billion years ago after the primary formation of the planet. The sky, which had quieted, suddenly turns violent again. A second massive bombardment of asteroids begins. But these are not ordinary rocks. They are metallic, remnant cores of shattered planetoids from the outer solar system, rich in the heavy elements that the Earth had lost. They rain down on the hardened crust. They vaporize on impact, spreading a fine, glittering dust of gold, platinum, and iridium across the entire globe. Over geological time, plate tectonics mixes this alien dust into the upper mantle and the crust, creating the veins of ore that we mine today. This means that the gold wedding band on your finger is not truly of this Earth. It is extraterrestrial debris. It is a remnant of a ghost bombardment that occurred in the dark gap between the formation of the planet and the rise of life. We are walking on a painted world, covered in a thin, precious layer of cosmic dust. This bombardment of asteroids and metallic debris painted our world with precious metals. It was a storm of small bodies, a rain of cosmic shrapnel that dusted the young Earth with treasure. Yet this violence was nothing compared to what came before it. There is a gap in our solar system's history that involves not mere asteroids, but an entire planet, a world the size of Mars that collided with us, merged with us, and whose shattered remains now hang over our heads every single night, glowing silver in the dark. The gaps in our history are usually voids, missing time, missing rock, missing air. But the biggest gap in the solar system is not an absence. It is a presence that hangs over our heads every single night. Look up at the moon. It seems silent, silver, and permanent. But to an astronomer, the moon is a crime scene. Its chemical composition is hauntingly similar to the Earth's mantle, yet it is bone dry and lacks iron. For a century, the math of its existence simply didn't add up. It was too large to be a captured asteroid, and it spun too fast to have formed alongside us from the same dust cloud. The physics pointed to a single, violent conclusion. The Earth was not born alone. 4.5 billion years ago, the early solar system was a chaotic shooting gallery. The proto-Earth was stalked by a sibling, a rogue planet roughly the size of Mars. We have named this lost world Theia, after the Greek Titan who gave birth to the moon. The collision was inevitable, but it was not a simple impact, it was a merger. Theia slammed into the Earth with a velocity that liquefied both worlds instantly. The crusts vaporized, the atmospheres burned. For a few thousand years, the Earth was not a rock, but a glowing torus of magma and gas. The debris from this catastrophe was blasted into orbit, forming a ring of fire that eventually coalesced into the moon. But here is the gap. Here is the missing piece of the puzzle that has plagued scientists for decades. If a Mars-sized planet hit us, where is it? In most collisions, the impactor shatters and scatters, or it glances off. But Theia vanished. It left no crater, no distinct layer on the surface. For a long time we assumed it had been thoroughly mixed into the molten soup of the Earth, its identity erased forever in the blender of the Hadean Eon. But the Earth has a memory. Recent seismic scans of the deep interior have revealed a ghostly anomaly. By listening to the way earthquake waves travel through the planet, geologists have mapped the deep mantle. And sitting there, just above the core, are two colossal, dense blobs of rock. One sits deep beneath West Africa. The other lies buried under the Pacific Ocean. These are not small pockets. They are continent-sized mountains, structures 100 times taller than Everest, denser and chemically distinct from the rest of the mantle. They are formerly known as large low-shear velocity provinces. But a more poetic and increasingly accepted theory suggests they are something else entirely. They are the corpse of Theia. The theory suggests that Theia didn't just mix, it sank. The heavy alien core of the impactor punched through the Earth's magma ocean like a bullet through water. It remained intact, settling at the bottom of the mantle, a dense alien sediment that has survived for 4.5 billion years. This means that when you stand on the ground, you are standing on a graveyard. The Earth is a chimera. We are living on a hybrid planet that has swallowed another world whole. The ghost planet is not missing. It is hiding in the basement, a silent, dense passenger riding through eternity inside our own world. Theia is a ghost obscured by 4 billion years of rock and fire, buried so deep beneath our feet that we needed the ears of modern seismology to hear its echo. Its invisibility makes a kind of sense. Time, after all, is the ultimate camouflage. The deeper we dig into the past, the fainter the evidence becomes. And yet, there are mysteries that defy this logic entirely. There are scars on the Earth that were inflicted not in the deep past, but yesterday, in geological terms, mere moments ago. Evidence of our planet's most recent cosmic assault lies scattered across 1/3 of the globe, and you can pick it up off the ground with your bare hands. But the crater itself, the wound that should be visible from space, has simply vanished. From the steam of the Vietnamese jungles to the red dust of the Australian outback, from the coast of Madagascar to the icy wastes of Antarctica, the ground is littered with peculiar black stones. They look like obsidian, sleek, glassy and aerodynamic, shaped into teardrops, dumbbells and buttons. These are tektites. They are not meteorites themselves. They are earth rock that was flash melted by a colossal impact, blasted into the upper atmosphere, and then rained back down as cooling glass. The distribution of these stones, known as the Australasian strewn field, is staggering. It covers roughly 10 to 30% of the Earth's surface. To scatter debris this far, the impact that created them must have been apocalyptic. Physics dictates that the asteroid responsible would have been perhaps 2 kilometers wide, slamming into the crust with the force of 1 million nuclear warheads. And it happened just 790,000 years ago. This is a heartbeat ago. Our ancestors, Homo erectus, were already walking the plains of Asia. They were making tools. They were using fire. They would have been witnesses. They would have looked up to see a second sun flash in the sky, brighter than the first. They would have felt the ground liquefy beneath their feet and heard the roar that shattered the air. A collision of this magnitude does not just leave glass beads, it leaves a hole. It should leave a crater perhaps 100 kilometers wide and kilometers deep, a scar that should be visible from the moon. We have found the craters for much older, much smaller impacts. We know exactly where the dinosaur killer hit in Mexico. But for this event, the most widespread debris field in recent history, there is nothing. For a century, geologists have scoured the map. They have analyzed the ocean floor for circular depressions using sonar. They have combed satellite imagery for ring structures. The crater is missing. It is the case of a gunshot victim where the bullet fragments are everywhere, but the entry wound has vanished. The mystery remained unsolved until very recently, when gravity scanners pointed to a remote corner of Southeast Asia. In the mountains of southern Laos, on the Bolavan Plateau, there is a vast field of volcanic lava. It is a thick, hardened blanket of basalt. Recent gravity anomaly scans suggest that beneath this heavy volcanic shield, buried in the dark, lies a massive, elliptical depression measuring roughly 13 by 17 kilometers. The Earth, it seems, committed the perfect crime. The theory is chilling. The impact was so violent that it cracked the crust deep enough to tap into a magma chamber. Immediately after the asteroid struck, the wounded Earth bled. It poured lava into the hole, filling the crater to the brim and sealing the evidence under a fresh layer of rock. We are left with a haunting realization. We are walking on a planet that is constantly repaving itself, paving over its own violence. The glass beads in the mud are the only testament to a day when the sky fell and the Earth swallowed the proof. If a crater can vanish in less than 1 million years, buried under lava, hidden beneath jungle, then what happens when the planet stops recording for far longer? What happens when the silence lasts not for a moment, not for 1 million years, but for 1 billion? We are leaving the era of violent impacts and sharp, sudden catastrophes. We are drifting now into a different kind of void, the era of the Great Stagnation, the longest, strangest, and most profoundly boring epoch in the history of the world. We expect history to be a sequence of events. Mountains rise, oceans open, animals evolve, and meteors fall. We expect progress. We expect noise. But in the middle of the Earth's timeline, there is a void that defies this expectation. It is a period that stretches from 1.8 billion years ago to 800 million years ago. Geologists, with a mix of frustration and awe, call this the boring billion. For 1,000 million years, a quarter of the planet's entire existence, the Earth seemingly pressed the pause button. If you were to time travel to this era, you would find a world trapped in stasis. The climate stabilized into a permanent, monotonous warmth. There were no great ice ages. There were no catastrophic heat spikes. The tectonic engine slowed down. The continents drifted together into a supercontinent called Nuna, and then later Rodinia. But the mountain building was sluggish. The restless surface calmed. But the true strangeness was in the ocean. The water was not the oxygen-rich blue we know today. It was stratified. The surface was oxygenated by simple bacteria, but the deep ocean was anoxic and sulfidic. It was a Canfield ocean. Imagine a global sea that smells of rotten eggs. The water is murky, perhaps stained a toxic purple by sulfur-loving bacteria. And in this chemical chokehold, life hit a glass ceiling. Evolution stalled. For 1 billion years, the dominant life forms were slime. Bacterial mats and simple single-celled eukaryotes drifted in the sludge. They did not grow large. They did not develop shells. They did not learn to crawl. They simply existed, trapped in a low-energy loop. The oxygen levels in the atmosphere hovered at a frustratingly low percentage, enough to keep the slime alive, but not enough to fuel the high-energy metabolism needed for complex animals. It was a planetary coma. This gap challenges our narrative of inevitable progress. It suggests that complex life is not a guarantee. It suggests that a planet can get stuck. For 1 billion years, Earth was a failed experiment, a stagnant pond waiting for a spark that wouldn't come. But the stasis could not last forever. The chemistry of the atmosphere was slowly, agonizingly changing. The slime was producing waste, and that waste was oxygen. But for that entire 1 billion years, the oxygen levels refused to rise. They hit a wall. To understand why the coma lasted so long and why it finally broke, we must look not at the rock or the fossils, but at the invisible fuel tank of evolution. We must examine the chemistry of the air itself. Because the boring billion was not just a geological stagnation, it was an atmospheric prison. Life was ready to explode. The blueprints for complexity existed, but the fuel line was clamped shut, and the key to understanding why lies in what scientists call the oxygen stall. The boring billion was defined by a stillness in the rock, but the true prison that held life captive was not in the ground. It was in the air. The stagnation of evolution was not a failure of biology, but a failure of the fuel tank. To understand why life remained trapped in the slime for so long, consider the history of our atmosphere. Logic suggests that once the first photosynthetic bacteria, the cyanobacteria, appeared, they began pumping out oxygen, and the levels should have risen smoothly until they reached the breathable 21% we enjoy today. It should have been a steady climb, but the geological record reveals a broken pattern. It reveals a stutter. 2.5 billion years ago, the Earth experienced the Great Oxidation Event. It was a revolution. Oxygen levels spiked. The iron dissolved in the ancient oceans, rusted and fell out of suspension, creating the vast red banded iron formations we mine today. The sky, previously orange with methane, turned blue. Then the engine choked. Instead of continuing to rise, the oxygen levels crashed. They plummeted back down to a meager fraction of modern levels, perhaps as low as 1%, or at best 10%. And then, for the next billion years, they flatlined. This is the oxygen stall. It presents a chemical mystery. The bacteria were still there. They were still photosynthesizing, still pumping out oxygen every single day of that long billion-year epoch. The gas should have built up. The answer lies in the toxic chemistry of the Canfield Ocean we encountered earlier. The deep ocean was saturated with hydrogen sulfide, produced by the sulfur-eating bacteria thriving in the dark. This gas is a voracious consumer of oxygen. As fast as the surface life could produce oxygen, the deep ocean chemistry was scrubbing it out. It was a planetary stalemate, a chemical war of attrition that lasted for 1,000 million years. This stall created a glass ceiling for life. Complex, active animals, creatures with muscles, nerves, and brains, are biologically expensive. They require a high-octane fuel. They need high levels of oxygen to burn sugar and generate the energy for movement. At 1% oxygen, or even 5%, a jellyfish cannot exist. A worm cannot exist. The Earth became a waiting room. The eukaryotic cells, the ancestors of all animals and plants, had evolved. The blueprint for complexity was ready. But the fuel line was clamped shut. They were forced to remain microscopic, drifting in the low-energy sludge, waiting for the atmosphere to break the deadlock. It is a humbling realization. Intelligent life was delayed for 1 billion years, not because evolution was slow, but because the planet's chemistry was stuck. We were held back by a sulfurous chokehold. Eventually, the stalemate broke. The chemistry shifted, the sulfur loosened its grip, and the oxygen began finally to climb. Yet the end of the boring billion did not come gently. It did not arrive as a gradual awakening, a slow sunrise after a long night. Instead, the planet lurched from one extreme to another. The hot, stagnant, sulfurous world plunged into a deep freeze so absolute, so total, that it nearly sterilized the globe entirely. The silence of the warm sludge was about to be replaced by the silence of ice. We are entering the Cryogenian period. This is the era of the Snowball Earth. This gap in the geological record was caused by a physical barrier. For nearly 70 million years, the oceans, the primary recording medium of history, were sealed off from the sky. Imagine looking at the Earth from space. 700 million years ago. You would not see the familiar blue marble. You would see a blindingly white, smooth sphere indistinguishable from the icy moons of Jupiter like Europa. The ice sheets did not stop at the poles. They marched relentlessly toward the equator, locking the tropics in a carapace of ice kilometers thick. The global temperature plummeted to -50 degrees Celsius. The silence of this world is difficult to conceive. The waves stopped. The ocean currents, driven by the wind and the sun, were dampened by the heavy lid of the ice. The evaporation cycle slowed to a crawl. The planet became a mirror, reflecting almost all the sun's energy back into the cold void of space, locking itself into a freezing feedback loop that seemed impossible to break. For the life that had spent the last billion years drifting in the lazy, warm slime of the oceans, this was the apocalypse. The sun was gone, blocked by the ice. The photosynthesis stopped. The food web collapsed. The geological record of this time is chaotic. It is a gap because the orderly layering of sediments ceased. Glaciers act as eroders, not recorders. They grind the bedrock into flour. We find strange dropstones in the rock record from this time. Massive boulders carried by icebergs and dropped into the fine mud of the equatorial seabed, a geological impossibility in any normal world. So, where did life go? For 70 million years, the fossil record is virtually blank. The surface of the planet was a dead zone, but biology is stubborn. We believe that life retreated into the last remaining refuges, the Cryogenian arcs. Perhaps life clung to the edges of volcanic islands that punched through the ice, huddled around the warmth of the lava. Or perhaps it retreated to the deep hydrothermal vents, living off the Earth's internal heat in the crushing dark. There is also the slush ball theory, which suggests that a narrow band of open water, a slushy, half-frozen mix, remained at the very equator, a final desperate trench where the sun could still touch the water. This gap represents a bottleneck. The population of living things on Earth was reduced to a fraction of what it had been. It was a genetic purge. But the ice was not just a prison. It was a pressure cooker. Isolation drives evolution. Separated into tiny, cut-off pockets of water, life was forced to adapt or die. The low resources, the cold, and the isolation may have forced single-celled organisms to do something revolutionary. To survive, they began to cooperate. They began to cling together, sharing resources, specializing their functions. The empty, frozen silence of the Cryogenian is likely the womb of the animal kingdom. It is the gap where we began. When the volcanoes finally pumped enough carbon dioxide into the atmosphere to shatter the freeze, when the ice cracked and retreated and the oceans opened up again, the world that emerged was not immediately safe. The Earth had walked out of the refrigerator, yes, but it had walked into a bath of radiation. The planet's invisible shield, the magnetic force field that protects us from the lethal wind of the sun, had grown dangerously weak, and in that moment of vulnerability, under skies that burned with strange light, life was about to change forever. There is a gap in the history of our planet's defense systems that coincides perfectly with the rise of the first animals. It is a moment when the invisible shield that protects us simply turned off. We take the Earth's magnetic field for granted. It is the invisible force field generated by the swirling molten iron in the outer core. It reaches thousands of miles into space, deflecting the solar wind and the cosmic rays that would otherwise strip away our atmosphere and mutate our DNA. It is the reason we are not Mars. But 565 million years ago, during the Ediacaran period, the engine faltered. Geologists have analyzed ancient crystals, tiny grains of plagioclase and pyroxene trapped in rocks from Quebec. These crystals act like frozen compasses. They lock in the strength and direction of the magnetic field at the precise moment they cool. And when we read the data from this specific window of time, the results are terrifying. The field strength had collapsed. It dropped to perhaps 10% of its current value. For millions of years, the Earth was effectively unshielded. The cause was deep underground. The planet's core was cooling, but it had not yet begun to solidify. The geodynamo, the convection of liquid metal that generates the field, was running out of thermal energy. It was becoming sluggish. The heartbeat of the planet was stopping. The Earth was on the verge of losing its atmosphere entirely, of becoming a dead, dry rock. But this weakness created a spectacle of haunting, dangerous beauty. In our world, the auroras, the northern and southern lights, are confined to the poles, where the magnetic field lines funnel the solar energy. But in the Ediacaran, with the field shattered and weak, the solar wind could strike anywhere. Imagine standing on a tropical beach 565 million years ago. The air is warm, the ice is gone, but when you look up at the night sky, you do not see just stars, you see fire. Great curtains of neon green, violet, and blood-red light dance directly overhead at the equator. The sky is constantly crackling with geomagnetic storms. The radiation is pouring down, bathing the shallow seas in high-energy particles. This sounds like a catastrophe. But in the strange logic of deep time, this magnetic collapse might have been the trigger for us. There is a controversial but compelling theory that links this collapse to the explosion of life. The weak magnetic field may have allowed the solar wind to strip away lighter gases from the upper atmosphere, inadvertently increasing the concentration of oxygen in the lower atmosphere. Or perhaps the radiation itself acted as a mutagen, increasing the rate of genetic error and variation, forcing life to experiment with new bodies and new shapes at a frantic pace. It was a window of vulnerability that became a window of opportunity. And just as the field reached its weakest point, just as the Earth seemed doomed to lose its atmosphere, a miracle occurred in the center of the planet. The inner core nucleated. The iron at the very center of the Earth froze solid. This sudden phase change released a massive burst of heat, kick-starting the convection in the outer core. The dynamo roared back to life. The shield went back up. But in that brief, unprotected interval, under the glow of the equatorial auroras, life had changed. The simple, single-celled world was gone. The radiation and the oxygen had conjured something new. Strange, soft-bodied and alien forms were drifting in the shallow water. They are the ghosts of the first complex life, creatures that have no eyes, no mouths, and no ancestors that we can trace. As the magnetic shield stabilized and the auroral fires retreated to the poles, the Earth settled into a new, quiet equilibrium. The stage was set for life to grow large, and it did. But the first rulers of the Earth were not animals as we understand them. They were biological phantoms that defy classification. If you were to swim in the shallow, sunlit seas of 575 million years ago, a time preserved in the fossil beds of the Ediacaran Hills in Australia or Mistaken Point in Newfoundland, you would find yourself in a world of profound, unsettling strangeness. There are no fish swimming in the water. There are no crabs scuttling on the sand. There is no coral. The seafloor is covered in a thick, leathery microbial mat, a carpet of bacteria that seals the sediment. And lying on top of this carpet, basking in the silence, are the Ediacarans. These are the soft giants. Imagine a creature like Dickinsonia. It looks like a ribbed oval bath mat, perhaps a meter long, lying flat against the sea floor. It has no head, no tail, no eyes, and no mouth. It has no gut. It is simply a quilted sheet of living tissue. It does not hunt. It does not graze. It likely absorbed nutrients directly from the bacterial mat beneath it or filtered organic molecules from the water through its skin. Next to it stands Charnia. It looks like a fern frond, a leaf anchored to the bottom in the dark, deep water. But it is not a plant. Plants need light, and Charnia lived in the pitch black. It is an animal that built itself using a fractal blueprint, a rangermorph. It grew by repeating the same pattern over and over at smaller scales, maximizing its surface area to soak up the carbon from the water. This was the Garden of Ediacara. It is the most peaceful time in the history of the planet. There were no predators. Nothing in this world had teeth. Nothing had claws. Nothing had a shell because there was no need for defense. The concept of hunting had not yet been invented. It was a slow, blind, soft-bodied paradise where life lay still and absorbed the energy of the world. But this entire ecosystem represents a massive, frustrating gap in the tree of life. For decades, paleontologists tried to shoehorn these creatures into modern categories. They tried to call them the ancestors of jellyfish, or worms, or lichen. But the more we study them, the more alien they appear. They do not seem to be our ancestors. They seem to be a lost dynasty, a failed experiment in multicellular life that flourished for 30 million years and then was completely erased. The gap comes at the end. 541 million years ago, the Ediacarans vanish. The rock record goes blank of these soft shapes. When the curtain rises again for the Cambrian period, the world is filled with hard shells, complex eyes, and swimming arthropods. What happened to the garden? The leading theory is the Cambrian substrate revolution. The new life forms, the worms and the early arthropods, did not just evolve. They engineered. They learned to burrow. They dug into the microbial mat that stabilized the sea floor, churning up the mud, destroying the firm foundation that the Ediacarans needed to anchor themselves. And they learned to eat meat. The Ediacarans were soft, immobile bags of nutrients in a world that was suddenly inventing the knife. They were defenseless. They were grazed out of existence, devoured by the ancestors of the modern animals. The gap here is total. We have no idea if any Ediacaran DNA survived into the modern world. They are likely a dead branch, a ghost lineage that proves life does not always progress in a straight line. Sometimes it builds a beautiful, complex world and then scrapes it clean to start over. The Ediacarans were erased by the invention of teeth and tunnels, their soft bodies devoured by the very animals they had unwittingly made room for. It was a tragedy of biology, a quiet apocalypse that left no bones to mourn. Yet the planet itself commits a far larger crime against memory every single day. While life struggles to leave its mark, the Earth is constantly destroying the canvas. We rely on the ocean floor to tell us the history of the deep, the sediment, the shells, the chemistry of ancient water. But there is a shocking, unsettling truth about that floor. It is young. It is impossibly, suspiciously young. If you were to walk across the ancient shield rock of Canada or the cratons of Western Australia, you would be standing on granite that is 3, perhaps 4 billion years old. These continental cores are the permanent archives of the planet, floating high and dry, preserving the scars of the deep past like wrinkles on an aging face. But if you were to descend into the abyss, to the bottom of the deepest ocean, and pick up a rock from the seafloor, you would find something mathematically disturbing. It would be young. The oldest piece of ocean floor on Earth, located in a quiet corner of the Western Pacific or the Mediterranean, is only about 200 million years old. The Earth is 4.5 billion years old. This means that for the first 95% of our planet's history, the physical record of the ocean is completely, irrevocably gone. It is the equivalent of a library that burns down every few weeks. The culprit is the mechanism of the planet itself. The ocean floor is not a permanent surface, it is a conveyor belt. It is born at the mid-ocean ridges, where magma bleeds up from the mantle to create new hot crust. It spreads out, cooling and becoming denser over millions of years, traveling across the globe like a slow-moving skin. And then it dies. When this heavy, cold, oceanic crust hits a continent, it loses the fight with gravity. It is dragged down into the subduction zones, the deep trenches that ring the Pacific. It slides back into the hot, viscous mantle from which it came, melting away, its atomic structure scrambled, its history rebooted. This process is planetary cannibalism. The Earth is constantly eating its own skin. This creates a profound gap in our understanding. We know that there were oceans before the Atlantic and the Pacific. We have names for them: the Iapetus Ocean, the Panthalassa, the Rhyic Ocean. But we know they existed only because we find the scars they left behind. The mountains formed when they closed. The oceans themselves, the seafloor, the seamounts, the hydrothermal vent systems, the islands that dotted their surface, are gone. They have been recycled into the magma that erupts from today's volcanoes. We are trying to reconstruct the history of the world while the planet is actively running the shredder. This geological amnesia has a devastating effect on our knowledge of life. The continents preserve their fossils in stone, but the vast majority of the Earth's surface is, and always has been, deep ocean. The creatures that lived in that abyss, the monsters of the midnight zone, the ecosystems of the trench, they lived on a floor that was destined to be melted. The history of the deep sea is almost entirely a blank page. We know less about the ancient abyss than we do about the surface of Mars, simply because the abyss refuses to keep a record. The destruction of the seafloor creates a shadow that stretches far beyond geology. It casts a veil of ignorance over the history of biology itself. Because the rock is eaten by the mantle, the creatures that lived upon it are erased, creating a specific, frustrating blindness regarding the largest ecosystem on our planet, the deep ocean. We tend to think of the abyss as a place of monsters. We send our titanium submersibles down into the midnight zone, shining lights into the crushing dark, and we bring back images of nightmare creatures that defy modern logic. We see the vampire squid, Vampiroteuthis infernalis, a dark red cloak of flesh studded with bioluminescent photophores. It is neither a squid nor an octopus, but a relic of a time before the two lineages split. We see the frilled shark, a serpent-like creature with rows of needle teeth that looks like it swam straight out of the Devonian period. We see the coelacanth, the famous Lazarus fish that was supposed to have died with the dinosaurs. These animals look ancient. They move with a slow, primitive grace that suggests they have been patrolling the dark for hundreds of millions of years. We call them living fossils. We assume they are survivors who retreated to the deep to escape the chaos of the surface. But here is the gap. We cannot prove it. The deep ocean floor is constantly recycled. The conveyor belt of plate tectonics drags the sediment and the bones down into the fire. Furthermore, deep-sea animals are often made of soft tissues, jelly, cartilage, and muscle that rots instantly. They lack the hard, heavy bones that fossilize well in shallow water. This creates a biological black box. Evolution in the deep sea happens in the dark, unrecorded. We have almost no physical evidence of how the anglerfish evolved its bioluminescent lure. We have no step-by-step record of how the giant squid grew to the size of a bus. The intermediate forms, the failed experiments, the ancestors, they are all gone. This abyssal silence means that we are missing the history of the majority of life on Earth. The deep ocean covers 60% of the planet. For eons, it has been a stable, cold, high-pressure refuge, a place where archaic forms could survive while the surface worlds burned and froze. It is likely that the deep sea is the museum of the Earth, filled with lineages that have survived every mass extinction event. But the museum has no catalogue. The exhibits are living, but their history books have been burned by subduction. We are left with a haunting sense of ignorance. We look at a creature like the colossal squid battling a sperm whale in the crushing dark, and we realize we are watching a war that has likely been waging for epochs, completely unknown to science, completely unrecorded by the stone. The ocean keeps its secrets. It swallows its own past. The gaps in the ocean's history are vast and impersonal, a tragedy of geology, a failure of stone to remember. Yet there are gaps that hit much closer to home. There are holes in the story that sits inside our own DNA. We like to think that the path to humanity is clear, a neat line of skulls marching from ape to human. But if you look closely at that line, you will see that it is fractured. There are moments where our ancestors seem to vanish into a fog, only to emerge thousands of generations later, changed, smarter, and stranger than before. When we think of our origins, a specific image usually comes to mind. It is the famous March of Progress. We see a line of figures walking from left to right. It starts with a stooped, knuckle-walking ape, then a slightly taller, hairier hominid, and finally, the upright, hairless, modern human holding a spear or a briefcase. It is a clean, unbroken line of improvement. But this image is a lie. The path that led to us is not a straight highway. It is a tangled, broken maze hidden in the fog of the East African Rift. The first major blackout occurs roughly 6 to 7 million years ago. This is the moment of the Great Split. Somewhere in the dense, ancient jungles of Africa, a population of ancestral apes divided. One group stayed in the trees. They became the chimpanzees. The other group stepped out onto the savanna. They became us. This is perhaps the most important moment in our history. But for this entire critical window, a span of millions of years, we have almost no fossils. We have a few teeth, a few fragments of skull like Sahelanthropus, but the film reel is essentially blank. We do not know who the first walker was. We do not know the face of the Eve that connects us to the apes. The acid soil of the rainforest likely dissolved their bones before they could turn to stone, erasing the very first chapter of the human story. But the more haunting gap comes later. Jump forward to 3 million years ago. We meet Australopithecus. This is Lucy. She walks upright, but she is small. Her brain is tiny, barely larger than a chimp's. She is, for all intents and purposes, a bipedal ape. Then the record flickers. When the light comes back on, around 2 million years ago, a new creature is standing on the plains. It is Homo erectus. This being is fundamentally different. It is tall, it hunts, it uses fire, but most importantly, its brain has exploded in size. In a geological blink of an eye, the cranial capacity has nearly doubled. This is the encephalization event, and it is a biological mystery. Evolution is usually slow. It works in small incremental steps over eons. But the jump from the small-brained grazer to the large-brained hunter is alarmingly fast. What drove it? Was it the sudden introduction of meat into the diet? Was it the chaos of a flickering climate that forced us to get smart or die? Or was it the invention of cooking, which allowed us to digest calories faster? The missing link is not a single bone. It is this transition. It is the missing manual that explains how an ape learned to ask questions. We are left with a skeleton that fits together, but a history that doesn't. We are a species with amnesia, waking up in a world we dominate without a clear memory of how we earned the crown. This silence covers not just our biological origins, but our history as a species that spread across the globe. We assume that once we became human, we simply walked out of Africa and conquered the world alone. But there are ghosts in our family tree. There are entire species of humans, people who lived, loved, spoke, and perhaps even sang, who have been erased so completely that they exist only as shadows in our own blood. The map of human evolution is crowded with cousins. We know the Neanderthals well. We have their skulls, their heavy spears, their flower-strewn burials. We can look into their heavy-browed faces in museum reconstructions. and recognize a reflection of ourselves. They are tangible, physical beings who left a clear mark on the caves of Europe. But in the vast eastern expanse of the ancient world, there is a silence. A ghost lineage haunts the continent of Asia, a species that ruled a territory stretching from the freezing steppes of Siberia to the steamy jungles of Southeast Asia. They are the Denisovans, and they are the ultimate example of a biological gap. In 2008, in a cold, wind-scoured cave in the Altai Mountains of Siberia, a tiny fragment was pulled from the dirt. It was not a complete skull. It was not a femur. It was the tip of a pinky finger bone belonging to a young girl who died 40,000 years ago. This single, insignificant chip of bone is almost the entirety of the physical evidence we have for a population that likely numbered in the hundreds of thousands. When geneticists extracted the DNA from that finger, the results were shocking. It did not match a modern human. It did not match a Neanderthal. It was something else, a third player in the game of dominance, a sister species that split from us hundreds of thousands of years ago and then vanished into the fog. The genetic map reveals that the Denisovans were survivors of the highest order. They adapted to environments that would kill a modern human. We find their genetic legacy today in the Sherpa people of the Himalayas, who carry a specific Denisovan gene that allows them to breathe easily in the thin, oxygen-poor air of the high mountains. We find their traces in the DNA of indigenous people in Papua New Guinea and Australia. This implies an empire. It implies that these ghosts of the Altai were not just hiding in a single cave in Russia. They were navigating the high plateaus of Tibet. They were crossing the Wallace Line into the islands of Indonesia. They were masters of a diverse, challenging world, perhaps for hundreds of thousands of years. So where are they? Where are their tools? Where are their campsites? Where are their graves? How can a species that lived for eons, a species that bred with us and shaped our very immune systems, leave behind nothing but a finger bone and a few scattered teeth? The gap here is likely one of geography and chemistry. Neanderthals lived in Europe in dry limestone caves that act as perfect vaults for preserving bone. But the Denisovans may have lived largely in the open or in the hot, humid tropics of Asia. In the jungle, biology destroys history. The soil is acidic and hungry. Bones rot, wood decays. The physical evidence of their lives was eaten by the forest floor. They are a reminder that the fossil record is biased. It favors the cave dwellers. It favors the dry. It erases the open wanderers. We are left with a haunting realization. We shared this planet with another intelligent mind. We looked into their eyes. We touched them. But the earth has swallowed their memory, leaving us alone in a room full of ghosts. The silence in our history is not always caused by the slow decay of bones or the hungry acid of jungle soil. Sometimes the silence is caused by the near extinction of the survivors themselves. There is a moment in our timeline, a specific, terrifying bottleneck, where the human voice almost flickered out entirely. A moment when fire fell from the sky and the world went dark, and only a handful of our ancestors survived to tell no tale at all. 74,000 years ago, the human story was just gaining momentum. Bands of early Homo sapiens were moving out of Africa, exploring the lush edges of the Middle East and Asia. We were adaptable, intelligent, and armed with fire. The population was healthy, diverse, and growing. We were poised to inherit the Earth. And then, the island of Sumatra detonated. The eruption of the Toba supervolcano was not a normal geological event, it was an apocalypse. It ejected roughly 3,000 cubic kilometers of rock and ash into the atmosphere. To put that in perspective, it was thousands of times more powerful than the eruption of Mount St. Helens. It blasted a hole in the stratosphere and released a sound that circled the globe multiple times. But the noise was the least of the problems. The ash was the killer. A dark, suffocating cloud spread globally, wrapping the planet in a grey shroud that blocked out the sun for years. The volcanic winter that followed shattered the climate. The global temperature plummeted by perhaps 5 degrees Celsius. The monsoon cycles, which brought essential rain to the tropical belts of Africa and India, failed completely. The lush grasslands turned into dust bowls. The forests withered in the dim light. In the face of this sudden freezing famine, humanity collapsed. When geneticists look at our DNA today, they see a shocking lack of diversity. Compared to a troop of chimpanzees living in a single forest, the entire human race, all 8 billion of us, are remarkably genetically similar. This similarity is a scar. It is the chemical evidence of a bottleneck. The models suggest that in the cold, starving aftermath of Toba, the total human population on Earth crashed. We were reduced to perhaps a few thousand breeding pairs. Some estimates suggest there were as few as 2,000 people left alive on the entire planet. Imagine the entire human race fitting into a single sports stadium, with empty seats stretching for miles around them. That was all that remained of us. Small, isolated bands of survivors clung to life on the coasts of South Africa, surviving on shellfish and tubers, huddled around fires in damp caves while the world outside froze. For 1,000 years, we teetered on the edge of extinction. We were an endangered species, no more significant to the planet than the rhino or the panda is today. This gap represents a silent century in our genetic memory. The diversity we had before the eruption, the clans, the languages, the lineages, was erased. We are the children of the lucky few. We are the descendants of the survivors who managed to endure the long, grey winter. This brush with extinction changed us. It forced us to innovate, to cooperate, and to push harder than ever before. Toba was a tragedy of the deep past, a challenge of fire, ash, and ice that nearly ended our story before it truly began. Yet there is another scar in our history that sits much closer to the surface. It is a line drawn in the dirt not 70,000 years ago, but just 12,000, practically yesterday in geological terms. It marks the sudden, violent end of a different set of giants and the beginning of the world we know today. It is a thin, dark layer of soil that separates the age of the mammoth from the age of man. If you dig a trench in the dry riverbanks of the San Pedro Valley in Arizona, or the plains of Chile, or even the fields of Belgium, you might find it. It is not a missing rock layer, it is an intrusion. It is a distinct, waxy, carbon-rich stripe running horizontally through the sediment, often less than an inch thick. Geologists call this the black mat. It dates to exactly 12,800 years ago. This date marks the onset of the younger Dryas, a sudden, inexplicable return to near-glacial conditions just as the world was warming up from the Ice Age. But the mat itself tells a story much more violent than a simple drop in temperature. It is a boundary line between two worlds. It is the curtain falling on the Pleistocene. Dig just a few inches below the mat, and the soil is teeming with evidence of a thundering ecosystem. You find the fossilized bones of the Columbian mammoth, the American camel, the dire wolf, and the giant ground sloths. You find the Clovis points, the beautifully crafted, fluted stone spearheads of the first widespread human culture in North America. It is a record of a vibrant, loud, and crowded landscape, a Serengeti of the Americas. But dig above the mat, and there is silence. The mammoths are gone, the camels are gone, the horses are gone. The Clovis people and their distinctive technology have vanished. The megafauna of the Americas was wiped out in a geological heartbeat. The biodiversity crashes to zero. What is the black mat? It is not just mud. When researchers analyze the chemistry of this dark soil under an electron microscope, they find materials that do not belong in a normal wetland. They find nanodiamonds, microscopic crystals that are formed only under intense shock pressure and high temperatures. They find anomalously high levels of iridium and platinum, heavy metals that are rare on the Earth's surface but common in asteroids. They find magnetic spherules, tiny balls of melted rock and iron that cooled in mid-air. This is the fingerprint of a cosmic arsonist. The leading theory, the younger Dryas impact hypothesis, suggests that the Ice Age didn't just end, it was murdered. A disintegrating comet, perhaps a fragment of the same celestial body that creates the torrid meteor stream today, slammed into the Earth. It likely did not hit the ground directly to leave a classic crater. Instead, it exploded in the atmosphere. An airburst of unimaginable heat, thousands of times more powerful than a nuclear weapon, detonated over the ice sheets of North America. The thermal pulse would have flash-melted the glaciers, triggering catastrophic floods, but it also would have ignited the world. The black mat is the soot. It is the charcoal of a continent-spanning wildfire that burned the forests and the grasslands to ash in a single day. It is the layer of dead vegetation, algal blooms, and charcoal that settled in the stagnant, soot-choked pools left behind by the fires. This gap, this black line, is the great divide of human memory. Below it lies the dream time, the world of monsters and giants and the first explorers. Above it lies the modern world, the Holocene, the time of agriculture and cities. We walk on top of the ashes of the world that came before. We have now looked at the missing biology, the missing planets, and the missing people. We have walked through gaps of every scale, from the vanished cousins in our bloodline to the cosmic impacts that reshaped continents. These are all missing pages or missing chapters in a book that remains, on the whole, remarkably thick. But there is one final gap that dwarfs them all. It is not a page or a chapter. It is a missing volume. A void so massive, so glaring, that it defies logic. It is a place where the Earth seems to have simply stopped recording time for over 1 billion years. And to see it, we must travel to the American Southwest. The epicenter of this silence is found in the American Southwest. The Grand Canyon is known to the world as a spectacle of erosion, a mile-deep testament to the power of the Colorado River cutting through stone. To the tourist standing at the rail, it is a view that inspires awe. But to a geologist looking at the strata, the canyon is a source of profound, vertigo-inducing confusion. It is a crime scene where the evidence has been removed on a planetary scale. The mystery reveals itself only at the bottom. Leaving the pine forests of the rim, the trail winds down past the red cliffs of the Supai Group and the grey walls of the Redwall limestone. The descent through the heat is a journey back in time, moving deeper into the earth with every step. Finally, in the inner gorge, where the river roars, the rock changes character completely. The walls here are made of something dark, twisted, and crystalline. This is the Vishnu schist. It is metamorphic rock, cooked by extreme pressure and heat deep in the roots of an ancient mountain range. Radiometric dating places these stones at 1.7 billion years old. They are the basement of the continent. Resting directly on top of this dark, chaotic basement is a layer of calm, horizontal brown rock called the Tektites sandstone. This stone is filled with the fossils of trilobites and burrowing worms. It dates to roughly 500 million years ago, the dawn of the Cambrian period. Now, imagine placing your hand on the line where they meet. Your thumb is touching the Tektites sandstone. Your pinky finger is touching the Vishnu schist. The physical distance between your fingers is less than an inch. But the distance in time is 1.2 billion years. In that single inch of empty space, more than 1 billion years of history have vanished. There is no rock. There are no fossils. There is no dust. an amount of time equivalent to 25% of the Earth's entire existence is simply gone. It is a void that swallows empires, mountain ranges, and oceans. This feature was named the Great Unconformity by the explorer John Wesley Powell in 1869. He stood in the canyon, looked at the gap, and realized he was facing a geological impossibility. Where are the sediments that should have accumulated during that billion years? Where is the debris of the mountains that must have eroded? The gap is so large that it defies the human capacity to visualize time. If the history of the Earth were a 24-hour clock, this gap represents 6 hours where the hands simply stopped moving or where someone erased the recording tape. For a long time, geology operated on the hope that this was a local anomaly. Perhaps Arizona was just high and dry for a billion years, a place where sediment never settled. But as researchers fanned out across the globe, chipping away at the oldest rocks on every continent, they found the same terrifying pattern. The gap in the canyon is not a mistake. It is not a quirk of the American desert. It is a symptom of a worldwide event, a planetary amnesia so complete that it demands an explanation beyond anything local or accidental. If this missing billion years were just a quirk of the American West, a local oddity caused by a rogue river or a specific tectonic uplift, it would be a geological footnote. But the canyon is not unique. It is merely the most photogenic example of a worldwide amnesia. As scientists expanded their search, dragging their hammers across the oldest surfaces of the planet, they realized that the pattern repeats with a haunting mathematical consistency. Go to the Ozark Plateau, hike the granite shields of Siberia, trek to the ancient cratons of China or the exposed bedrock of Saudi Arabia. The story is identical. Everywhere you look, the crystalline basement rocks, the ancient roots of the continents, are shaved flat, and sitting directly on top of them, separated by that same razor-sharp line, is the sediment of the Cambrian explosion. The Great Unconformity is not a local scar. It is a planetary wound. It suggests that across the entire globe, on every single landmass, the geological clock stopped running at the same time. Or rather, the recording tape was erased. The scale of this loss is difficult to calculate in terms of years, so we must calculate it in terms of rock. To create a gap of this magnitude, you do not just stop depositing sediment. You have to actively remove what was already there. You have to destroy the evidence. Geologists estimate that to create the surface we see at the bottom of the Grand Canyon, a layer of crust roughly 3 to 5 vertical kilometers thick was stripped away. Think about that volume. 3 vertical kilometers of solid rock ground into dust and washed away across the surface of every continent on Earth. It is a volume of material so vast that it would fill the Mediterranean Sea 100 times over. It is a mass excavation. It is as if a giant lathe turned the Earth, peeling away the outer skin of the continents down to the fresh bone beneath. For decades, this global erasure was the dark matter of geology, something we could see but could not explain. There is no river on Earth powerful enough to scour the entire world. There is no wind strong enough to sandblast a continent flat. The erosion rates of the modern world are too slow. Rain and wind would take tens of billions of years to achieve this level of flattening. To strip the world this naked, to exhume the deep basement rock on a global scale, you need a mechanism of unimaginable power. You need a bulldozer the size of a hemisphere. You need a force that scrapes the land clean, not with water, but with ice. The leading suspect for this crime against history is a climate event we have already met. The glaciers of the Snowball Earth, the very ice that sealed the oceans and nearly froze life out of existence, may also have been the executioners of the geological record. The rock was not just erased, it was ground away by the cold. To strip the skin off a planet, To remove 3 vertical kilometers of granite and sandstone from the face of every continent, you need a tool harder than rock and heavier than water. You need a machine that operates on a global scale, applying relentless, crushing friction for millions of years. Wind is too weak. Rain is too gentle. There is only one force in nature capable of this level of violence. The culprit is ice. The timing of the Great Unconformity provides the critical clue. The missing year's end and the rock record resumes right around the time of the Cryogenian period, the era of Snowball Earth. We must reimagine the glaciers. We are used to seeing them as they are today, retreating white rivers confined to the mountain valleys of the Alps or the ice caps of Antarctica. But 700 million years ago, the glaciers were not confined. They were conquerors. As the planet froze, vast ice sheets nucleated on the continents. They grew until they were 3, perhaps 4 kilometers thick. The weight of this ice is difficult to comprehend. A single cubic meter of ice weighs nearly a ton. A column of ice 4 kilometers high exerts a pressure on the bedrock that causes the crust itself to bend and crack. But the ice did not just sit there, it moved. Glaciers are fluid. Driven by gravity and their own colossal weight, they flow. And as they flow, they act as the ultimate sandpaper. The bottom of a glacier is not smooth ice. It is studded with boulders, rocks, and grit that it has picked up along the way. It is a diamond-tipped file dragging across the surface of the world. This process is called glacial scouring. Imagine the sound of this era. It is not the howling of the wind, but a deep, constant, subterranean scream, the sound of the continent being ground down. The ice sheets sheared off the tops of the mountains. They gouged out the valleys. They planed the rough, volcanic landscape of the ancient Earth down to a smooth, flat table. The Great Unconformity is essentially the floor of the glacier. It is the surface that was left behind after the ice had finished its work. The scientists who support this glacial bulldozer theory point to the math. They calculate that the average rate of glacial erosion is high enough that, over the course of the Snowball Earth events, the ice could easily have stripped away those missing vertical kilometers of crust. The ice ate the history. It pulverized 1 billion years of rock into flour. But matter cannot be destroyed. It can only be moved. If the continents were stripped bare, where did the debris go? Where are the missing mountains? They were pushed into the sea. As the glaciers reached the coastlines, they dumped trillions of tons of glacial flour, finely ground rock dust, into the oceans. This sediment didn't just disappear. It settled in the deep trenches or was subducted back into the mantle. The missing history of the Grand Canyon is likely sitting at the bottom of a subduction zone melted back into magma. But this act of destruction had a side effect. It was not just an erasure, it was a fertilization. The rock dust that the glaciers dumped into the sea was rich in minerals. It was loaded with iron, phosphorus, and calcium, the essential nutrients for life. When the ice finally melted, when the snowball thawed, the oceans were not just refilled with water, they were refilled with a chemical soup of unprecedented richness. The glaciers had scraped the continents clean and served the nutrients to the ocean. This leads us to a profound realization about the gap in the canyon. The Great Unconformity is not just a missing chapter. It might be the reason we are here at all. The destruction of the old world may have been the fuel for the explosion of the new one. Yet the ice was not the only force at work. While the glaciers were grinding the surface from above, another mechanism was attacking the continents from below. While the glaciers were grinding the surface from above, another force was attacking the continents from below. The glacial bulldozer is a compelling theory, but it is not the only suspect in the case of the missing billion years. There is a second mechanism, a violent upheaval of the crust itself, that may have prepared the ground for the ice. To find it, we must look at the death of a supercontinent. 750 million years ago, the landmass of Rodinia, that desolate, red, barren mother continent, began to tear itself apart. But before it broke, it rose. A supercontinent acts as a thermal blanket. It sits over the mantle like a heavy lid, trapping the heat rising from the core. Eventually, the heat builds up until the crust can no longer contain it. It arches upward. It creates a superplume, a massive upwelling of magma that lifts the entire continent kilometers into the air. This is tectonic uplift. Imagine the scale of this event. The crust of Rodinia did not just crack, it domed. Vast regions of the continent were thrust up into the path of the jet streams, into the path of the rain and the wind. In geology, height is a death sentence. The higher a mountain rises, the faster it is destroyed. Gravity gives water energy. Rain, falling on a high plateau, strikes with more force. Rivers, flowing down steep gradients, cut deeper canyons. By lifting the continent, the Earth triggered a phase of hyper-erosion. The rivers of the late Proterozoic became buzzsaws. They carved through the billion-year-old bedrock, stripping away the sediment, stripping away the history, and dumping it all into the widening rift valleys that would become the new oceans. This tectonic violence worked in a deadly feedback loop with the climate. As the fresh rock was exposed and pulverized by the rain, it reacted chemically with the atmosphere. It sucked carbon dioxide out of the sky, the silicate weathering mechanism we have seen before. The breakup of Rodinia didn't just strip the land, it froze the world. The uplift caused the erosion caused the cooling, and the cooling brought the glaciers. It was a conspiracy of systems. The fire from below lifted the rock up to be eaten by the rain, and the ice from above finished the job, scraping the table clean. Whether by ice or by uplift, the result was the same. The ancient, towering mountains of the pre-Cambrian were erased. The high continents were planed flat. The world was reduced to a low, smooth, featureless platform, a blank canvas waiting for the paint. And then the sea returned. As the ice melted and the ocean ridges expanded, the global sea level rose. It flooded these newly flattened continents, creating vast, shallow, sunlit inland seas that stretched from the coast to the interior. This was the great transgression. And it is in these shallow, nutrient-rich waters, washing over the fresh scars of the great unconformity, that the final and most important piece of the puzzle clicks into place. The great unconformity is a void in the rock, a missing billion years of history. But looking at it as a simple loss is a mistake. It is not just an empty space, it is a smoking gun. There is a direct causal link between the destruction of the old world and the sudden, riotous birth of the new one. The timing is too perfect to be a coincidence. Immediately above the line of the great unconformity, resting right on top of that eroded, planned-off surface, we find the Tektites sandstone and its global equivalents. And inside that sandstone, for the first time in the history of the planet, we find complex, hard-shelled animals. We find trilobites. We find brachiopods. We find the explosion of life known as the Cambrian. The question is, why? Why did life wait for 3 billion years in the soft-bodied microbial waiting room, only to explode into complexity the moment the erosion stopped? The answer lies in the chemistry of the dust. When the Glacial Bulldozers and the tectonic uplift scoured the continents, they didn't just remove rock, they dumped a specific chemical payload into the oceans. The glaciers pulverized the granite crust into a fine powder, exposing fresh minerals to the seawater. This glacial flour was rich in ions, calcium, potassium, iron, and silica. For millions of years, the erosion pumped these minerals into the sea. It changed the alkalinity of the global ocean. It turned the water into a supersaturated chemical soup. Before this moment, building a skeleton was expensive. It required immense metabolic energy to pull calcium carbonate out of the water to make a shell. The Ediacarans were soft because the ocean didn't let them be hard. But the Great Unconformity changed the equation. The erosion dumped so much calcium into the water that the ocean became a factory for bone and shell. This triggered the biomineralization event. Suddenly, life didn't just have to exist, it could build. Animals began to pull the minerals from the water and precipitate them into their own tissues. They built armor, they built teeth, they built spines. The soft, vulnerable world of the Ediacarans was replaced by a world of hunters and tanks. The trilobites developed crystal eyes made of calcite. The Anomalocaris developed grasping claws. The evolutionary arms race began. This leads to a profound realization about the gap. The Great Unconformity is not a tragedy of lost records. It is the reason we are here. If the glaciers and the rain had not stripped the continents down to the bone, the ocean would never have received the chemical injection it needed to support complex life. The missing billion years were the price the Earth paid to build the modern biosphere. The planet had to destroy its past to fuel its future. The gap is the trigger. We have traced the voids from the missing biology of our ancestors to the missing geology of the canyon. We have seen how the Earth forgets, through erosion and acid, through ice and fire, through the slow recycling of its own crust. These are the mechanisms of ancient amnesia. But as we move into the modern era, into the time of humans, the nature of the gap changes. We are no longer just the observers of missing time. We are the creators of it. We are currently building a new kind of void, one that will baffle the geologists of the deep future and perhaps erase us entirely. We have spent this journey looking back, trying to read the torn pages of the Earth's autobiography. But now the perspective shifts. We are no longer just the readers of the gaps. We are the authors. And we must ask what kind of silence we are creating for the future. We live in the information age. We generate more data in a single day than civilization generated in the previous 2,000 years combined. Every thought, every transaction, every photo, and every song is recorded. We assume that because we are recording everything, we will be remembered forever. We assume our history is safe. But consider this. A stone tablet carved by a Sumerian scribe 5,000 years ago is still readable today. A clay tablet baked in a fire is permanent. Parchment can last a millennium. But a hard drive, a magnetic tape, a solid-state server, they have a lifespan measured in years, perhaps a decade. We are encoding our civilization into electrons and magnetic fields. We are writing our history in a language of ones and zeros that requires a constant supply of electricity and complex, specific machines to read. If the power goes out, the history vanishes. If the software formats change, the data becomes a locked box without a key. Archivists call this the digital dark age. Imagine a future historian, 1,000 years from now, digging through the ruins of a 21st century city. They find our smartphones, they find our server farms, but the screens are black. The magnetic charges on the drives have dissipated into entropy. The cloud has evaporated. They will find the empty shells of our technology, the black mirrors we stared into, but they will not find the data. They will not find our emails, our photos, or our digital art. Paradoxically, the century that screamed the loudest, the century that produced the most noise, may be the most silent century in the historical record. We are creating a gap of our own making, a void where the details of our daily lives, stored on fragile silicon, simply rot away. We are trading physical permanence for digital convenience, and in doing so, we may become the ghosts of the future. Yet, while our words and images may vanish into the electronic ether, there is something else we are leaving behind. A material that does not rot. A substance that nature never invented, which will form a distinct, unnatural layer in the geology of the future. Our digital legacy may fade, but our garbage will endure. If the digital world is a ghost, the physical world we are building is a scar. When the future geologist, perhaps human, perhaps something else entirely, looks at the strata of our time, the Anthropocene, they will see a distinct line. It will not be a gap of erosion like the Grand Canyon, nor a chemical stain like the Black Mat. It will be a synthetic horizon. It will be the plastic layer. We produce 300 million tons of plastic every year. We use it for minutes, and then we throw it away. But away does not exist in a closed planetary system. The plastic flows into the rivers, settles in the oceans, and is buried in landfills. Plastic does not decay in the biological sense. It does not return to the soil. It photodegrades. It breaks into smaller and smaller pieces, turning into microplastics that permeate the water column and the sediment. But under the heat and pressure of burial, or the heat of a beach bonfire, something strange happens. The plastic melts, it fuses with the rock. Geologists have already found these new hybrids on the beaches of Hawaii. They call them plastiglomerates. Imagine a rock that is half basalt, half melted toothbrush, a stone where the sediment is glued together by the solidified remains of fishing nets and bottle caps. This is the lithology of the future. In 10 million years, this will be compressed into a hard, distinct band of rock running globally through the crust. It will be colourful, flecks of unnatural blue, bright red, and synthetic yellow embedded in the grey shale. It will be a chemical anomaly, a layer rich in hydrocarbons but lacking the cellular structure of life. This layer will mark the technosphere. It will be the golden spike that defines our time. It will tell the future observers that for a brief, frantic moment in deep time, a species learned to manipulate the molecular bond of carbon, but did not learn how to close the loop. It is a sobering legacy. Our thoughts, our digital souls, will fade into the digital dark age, but our garbage will become geology. It will be the only thing that bridges the gap between us and the deep future. This realization brings us to the edge of a final, unsettling question. We have looked at the gaps in the rock, the gaps in the ice, and the gaps in the data. We have seen how we are creating our own silence in the geological record. But this prompts a terrifying thought, one that borders on science fiction, yet is asked by serious scientists. If the Earth is so good at erasing history, if it can hide a planet like Theia or a civilization like the Ediacarans, could it have hidden something else? Could we be the second time this has happened? The plastic layer and the radioactive spike are the monuments of our time. They are the chemical signature of intelligence manipulating the world. But this realization leads us to a question that borders on science fiction, yet is asked by serious climatologists and astrophysicists. It is a thought experiment known as the Silurian Hypothesis. We assume that we are the first. We look at our cities, our networks, and our global footprint, and we believe that we are the singular pinnacle of intelligence on this planet. We assume the history of the Earth is a linear story leading inevitably to us. But the Earth is 4.5 billion years old. Modern industrial humanity has existed for perhaps 300 years. That is a ratio so small it is statistically negligible. The hypothesis asks a simple, unsettling